Good afternoon, everyone, and welcome to the second Graduate Research Colloquium of the Institute of Civil Engineering. This colloquium is live via YouTube, and of course, we have participants here on Zoom. No? The Graduate Research Colloquium, as you already may know, is open to all undergraduate and graduate students, scholars, faculty, and researchers, as well as professionals, no? Who are practicing, in the various fields and subfields of civil engineering. And today uh, marks the second graduate research colloquium, no, after quite a long spiel, no, due to the pandemic. No, we were supposed to hold the second graduate research colloquium last year, no, but because of the circumstances, we decided to cancel the event. No. However, this year, after much adjustments, including virtual learning experiences, we decided to push through, no, with the graduate research colloquium. And the objective is actually to offer this, no, host this more regularly, no, more frequently. No? So after this colloquium, we ask everyone to watch out for the next colloquia, that we will be hosting at ICE. So this is a photo taken during the first graduate research colloquium back in May 2019. No? This was held at the ICE main building, and we had participants not just from UP but also from other universities, other schools as well. And we had a very good dynamic, interactive, open forum, no, after the presentations during that colloquium. The GRC, as we call it, no, aims to showcase the research projects and other scholarly activity conducted by current graduate students of the UPICE graduate programs and allied fields. So these are students basically in the Master of Science in Civil Engineering program, as well as the PhD Civil Engineering program of the Institute of Civil Engineering of UP Diliman. And we hope to use this, no, as a venue for students to present parts of their research project proposals, the progress, no, of their research work, or the output, no, of their research. No? So some of these presentations might already be post-defense, no? Presentations from our students. And hopefully we can solicit your comments, your maybe recommendations, no, regarding this research work. No? So later, we do expect questions, comments, recommendations, no, from the participants, no, in order for us to enrich, no, yung discussion as well as yung mga research na kinoconduct natin. And we do understand that some of the participants are also maybe looking for research topics. So allow us, no, to present what we have been doing, and perhaps, no, you can pick up a topic or two, no, that you would be interested in as far as your work is concerned. No? Baka may mga naghahanap ng mga thesis topic, dissertation topic. So sana po may ma-pick up tayo dito sa mga ipe-present this afternoon. But aside from these, no, so allow us to also mention that the Institute has a research agenda, and this research agenda, no, is according to the 6 groups. No? In UP Institute of Civil Engineering, we have 6 groups. That is the Construction Engineering and Management Group, the Water Resources and Coastal Engineering Group, the Geotechnical Engineering Group, the Structural Engineering Group, the Environmental and Energy Engineering Group, and the Transportation Engineering Group. And each of these groups would have their own research agenda. So I won't go into that anymore this afternoon. No? And but I wanted to share, no, some of the recent and ongoing research projects of the institute, no, and the details of which, no, may be found also on our Facebook page, no, on our social media account. And as you can see from the following slides, there are also, of course, the contact information of the project leads, no? So you're very welcome to connect with them if you're interested in their topics, no? And perhaps if you want to also pick their minds, no, regarding the prospective topics na siguro gusto nyo i-develop, you may also contact them. So just a run through, no, of some of the projects being undertaken at the university. We have here yung e-trams project, enhancement of transportation management software. The project lead is Dr. Sean Palmiano, who is also head of our transportation engineering group. And this is part of their Intelligent Transport Systems Laboratory, which is hosted by the National Center for Transportation Studies. No? There's also this project, Data Strengthening for Child Road Traffic Injury Prevention, a project which is supported by the UNICEF. The project leads here are Dr. Rick Sigua and yours truly, Regine Regidor. I think hindi ko yata na-introduce yung sarili ko. I'm the graduate program coordinator of the Institute of Civil Engineering. And as far as this project is concerned, we completed phase 1 last June, and we're now entering phase 2 from November. So yun yung formality about this project. So continuation until I understand until 2023, no, yun yung phase 2 namin. There's also a project recently completed. This is about modeling estimation of the transport energy demand in the Philippines. The project lead here is Dr. Carl Verhel, and this was funded by the Energy Research Fund of the UP Office of the Vice President for Academic Affairs. The Energy Research Fund was a fund provided by the office of Senator Win Gatchalian, who is the chair of the Senate Energy Committee. We have several DOST funded projects at the center, and you can see one of them here. Incidentally, yung kay Dr. Palmiano kanina was also funded by the DOST, yung e-trams project na yun. This one is Project Swerve. The lead is Assistant Professor Tim Acosta. So this is about enhanced severe wind vulnerability curves for key building types. Okay. And then we have also this ongoing to layer, right? Characterization of plastic, okay, in urban rivers leading to Laguna Lake. Okay. And we also have the project, no, for Philippine electrochemical arsenic remediation. Okay. And the project here, this is a PICARI project, I believe, is led by Dr. Ogie Resurrection. No? And then we have the IWASTO project, integrated waste analysis. I hope I pronounced that right. Integrated waste analysis, survey and technological options. This is also funded by the DOST. The project lead is our director, Dr. Tonette Tanchuling. And then you have here under Project SMART, the ecosystem modeling and material transport analysis for the rehabilitation of Manila Bay, which is led by our research coordinator, Dr. Eugene Herrera. We also have the project, no, on the determination of appropriate expansion of perlite to conform to standards of lightweight aggregates for use in construction. This is led by Assistant Professor Bel Karam. No? So these are among and I think this is a newer project, no, ongoing. The prototype automated visual survey equipment or PAVE project, no, which is led by Dr. Leia Brunuela Ambrosio. No? So this is about pavement engineering. So these are just some of the projects ongoing. No? Just to mention a few that are also funded by various institutions, especially the DOST, no? Through the mainly through PSHERD. Okay, and of course the institute has been blessed with a number of projects also that are supported by international institutions as well, no? As well as private funding. So this afternoon, we have for you 6 presentations. No? These 6 presentations are from the various groups comprising the Institute of Civil Engineering. And yeah, without further ado, we'd like to show the presentation. So we asked each speaker to prepare a 10-minute presentation, which will be playing for you. No? In the interest of time, we'll be presenting all the videos first, no? And then afterwards, we will be having an open forum. Okay. And maybe some few more remarks for the participants. Since we'll be showing the presentations, no, one after the other, we'll be asking you to first maybe kung may nagbabagang questions dyan, no? So please type in your questions in the Q&A box. Okay? Wag po sa chat, dun sa Q&A box po natin i-type, no? And we'll ask our presenters, no, to type in their answers, or if they prefer, they may take on those questions live later during the open forum. So ganun na lang ang gagawin natin, no? So speakers, please do try to answer some of the questions that might come your way, no? While we are showing the presentations this afternoon. So maybe I'll ask Assistant Professor Leia Diola just to mention, acknowledge some of our participants this afternoon. Leia?
So again, welcome to UPICE Second Graduate Research Colloquium. Thank you very much for attending. So for the first batch muna nang nag-register,
yes,
no?
Yes.
So
I understand marami, no? May long list tayo ng mga participants, but we'll just mention the universities and companies who are participating this afternoon.
Yeah, so we are very happy that many undergraduate and graduate students, as well as professionals, are joining us. So let me acknowledge the students of course, Institute of Civil Engineering, UP Diliman. We also have participants from Adamson University, Aklan State University, Ateneo de Naga University, Batangas State University, Bicol University, Cagayan State University, Cebu Institute of Technology, Cebu Technological University, Central Luzon State University, De La Salle University, Don Honorio Ventura State University, Eastern Visayas State University, Yuloyo Amang Rodriguez Institute of Science and Technology, FEU Institute of Technology. We also have a registrant from IHE, the Institute for Water Education, and Mapua University. So I think I can stop here for now, Sir Reg.
Thank you, Leia. And yeah, allow me to stop sharing this set of slides and go into the presentations. Our first presentation this afternoon is, wait, I think I pressed the wrong one. Sorry about that. Oops, bakit hindi lumalabas yung tamang presentation? Okay, so the first presentation this afternoon is from Rochi Amolato. And he's presenting on integrating user preferences using multi-criteria decision analysis to evaluate possible rainwater harvesting alternatives, a case for Teresa Rizal.
My co-authors, Dr. Joanna Resurrection and Assistant Professor Max Salomé. Our study is entitled Integrating User Preferences Using Multi-Criteria Decision Analysis to Evaluate Possible Rainwater Harvesting Alternatives, a case for Teresa Rizal. So a brief introduction, about 4.3 billion people, or about 71% of the global population, are considered to be in moderate to severe water scarcity for at least 1 month in a year. And for Metro Manila, it's expected that water demand rises to 800 million liters per day to 2025. Now, the most water-stressed areas are considered to be the rural areas, as these have the lowest service provision and are the least water communities, according to the ADP. Now, one alternative that we can propose to for this shortage in water supply would be rainwater harvesting. Now, for the Philippines, we only harvest about 6% of the rainfall that we can collect, and we collect about 4,000 millimeters per year on average. Compared to other countries such as India, they only have 700 millimeters, but they are able to harvest 60%. So there is some catching up to make here so that we are able to harvest more of our available rainfall. So for the methodology of this study, we use a multi-criteria decision analysis, which is a decision tool that integrates different criteria and evaluates different different alternatives to decide which option is going to be the most preferred. So this is useful when we're compiling assessments of different stakeholder preferences. Also, we've used the YAS algorithm, which incorporates the rational method to obtain rainfall volume. This also assumes the yield or the amount that the system is able to supply for water use, and is determined by either the smaller of the demand or yesterday's storage volume. And both of these are shown in these formulas here. So our study area is Teresa Rizal. It is located about 32 kilometers to east of Metro Manila and is about close to 60,000 population. It's composed of about 9 barangays, and of those 9 barangays, 3 barangays experience a weekly to daily water interruption. And it would be good to use this as a scenario for what would be the preferences for those with less water interruption than those with more frequent use. So for the framework, for the multi-criteria decision analysis, we've used 4 factors, which is reliability, total cost, adaptability, and benefits. So these 4 factors have different weights that may change depending on the scenario that we will be considering, but also a general scenario will also be provided. So for the survey conducted, there was a preliminary survey was first done. This was a closed group of at least 20 people, and we tried to create the first relevant criteria. So here at this stage, we wanted to remove the research bias that we might have introduced. So we wanted to confirm those through the preliminary survey. Then the main survey, along with an EIC or information education campaign, was done. This was to inform the people of the respondents of what are the other preferences, other alternatives for rainwater harvesting, and the basic knowledge of rainwater harvesting. So we surveyed 329 people online, and we made them rate the importance of factors in a 4-point scale. So the output for this was water demand estimate. We also used that survey to estimate the water demand and their preferences and weights. So for problem and parameters, we've obtained the averages, roof area, household size, and the water demand from the survey. We also had runoff coefficient from references, and the rainfall data was from local rainfall stations that measures average and daily rainfall. So for the formulation of alternatives, 4 alternatives were chosen. We had a metal tank, a ferro cement tank, a plastic tank, and a built-in commercial plastic tank. All of these alternatives are available locally or can be locally assembled. And those were one of the factors for also choosing these alternatives. So here we have our transformation functions. The transformation functions are functions that have inputs for such as the rainfall, and then we convert that into how much water will be saved using the storage alternative or the rainwater harvesting alternative. Also for the emergency water supply, it's also done, and also for stormwater retention to prevent flooding. So the main survey concerns, and these were the results, about 2/3 experience either not enough water supply or frequent water interruptions. So the main problems with rainwater harvesting, or WH, is the source. It's a possible source of mosquito, and that they somehow consider roof water to be dirty. So I believe these 2 factors are strong factors that are probably hindering people in adopting such systems. They also want to use mainly for the water that will be harvested for toilet flushing, watering plants, and cleaning. And note that all of these 3 are for non-potable uses and will be reflected in the water demand that the rainwater harvesting systems will supply. About 81% of them want to harvest rainwater. So there's actually a large percent of them that actually want to harvest rainwater. And 76% would still collect rainwater, even though it might only be available during the rainy season. So this is the main result for the MCDA, wherein these are the scores for the different factors given the different alternatives. And note that the highest scoring alternative here would be the P10 alternative, or the plastic tank with a 1,000 liter storage size. So this alternative is likely to be the chosen one, or the one that had the highest score, due to its sort of balance of factors. It's a middle ground between factors. Thus, it's able to provide such balance of the different factors. So for that, what comes next is the F30 and F50 alternatives, which are the ferro cement tanks and have 3,000 liter storage size and 5,000 liter storage size. And these storages are said to be the most cost efficient given the storage size. So we've also considered a high scenario income. For the high scenario income, the people with higher incomes chose price, maintenance, and durability. For them, it was more important. So there was a higher value for them for that. So with that, we considered these factors to have more weight for them. And this is actually the change for them. For them, the F50 alternative becomes the more preferred because for them, they value the maintenance, price, and durability. And the F50 is able to provide better durability. Also, for a future scenario, the highest scoring alternative would be the F50 because the F50 is able to provide more reliable given less rainfall and probable more demand. It's able because of its larger storage. So in conclusion, about 2/3 of the respondents experience problems from their current water supply. 76% are willing to harvest rainwater, even though it's only available during the rainy seasons. And their most concerns are mainly about presence of mosquitoes and dirt washrooms. P10 is the most preferred criteria since it has a balance of cost and reliability, with F30 and F50 coming next. So when we consider high-income residents, their preferences shifted towards the F50 alternatives, and so was the future scenario shifting towards F50 alternative, as this is able to provide the reliability and durability for these scenarios. So that's it. Thank you everyone for listening.
Thank you, Rochi, and apologies for the technical difficulties earlier during the presentation start. No? And so like what we said, we'll be running the presentations first, and then we'll have the open forum later. But in the meantime, you may post your questions in the Q&A box of our Zoom, and perhaps our presenters would be able to answer your questions. No? So kung meron kayong naisip kagad na tanong, paki-post na lang doon. Our second presenter is Mr. Matthew Travis Alcantara. And his presentation is on the development of a J2 plasticity model based on the modified Ramberg-Osgood power law for the analysis of progressive failure of soils with strain softening behavior. This is a progress report of his ongoing research.
Good afternoon, everyone. My name is Matthew Travis Alcantara, and I'm here to present my thesis on the development of a J2 plasticity model based on the modified Ramberg-Osgood power law for the analysis of progressive failure of soils with strain softening behavior. This is still a work in progress, and in this study, I'm mentored by Dr. Mark Albert Sarko. First, let's define what progressive failure is. Progressive failure is the process of successive failure of individual soil elements in a soil mass, which spreads in space and requires time to occur. So an initial failure surface will come out, and then succeeding failure surfaces will develop. So strain softening is the deterioration of material strength with increase in strain. In geotechnical materials, this phenomenon can be observed in very dense sands, stiff clays, and soft rocks. Progressive failures, as we described earlier, are typically associated with strain softening soils. So how do we analyze these progressive failures? In this study, we aim to develop a plasticity model which utilizes the stress-strain behavior of a soil sample in the finite element analysis of progressive failures. So we do that by getting the strength test results from the laboratory and then use the modified Ramberg-Osgood power law to create a mathematical expression for these strength test results. And then we incorporate this mathematical expression to the J2 plasticity model, which allows us to determine the stress during the plastic deformation. And then we incorporate this in the finite element analysis, in which we include the problem geometry and loading, which gives us the geotechnical analysis of these progressive failures. So let's start with the modified Ramberg-Osgood power law. This is developed by Reyes and Alcantara in 1993, in which it was devised to represent a stress-strain curve of soils with strain softening behavior, and it is represented by this mathematical equation. So in here we have four parameters. S and E are stress and strain measures, and then N and M. So this equation represents the backbone curve of the normalized stresses and strains, in which if we nominate values for N, M, and then E and solve for S, we can get this a curve that looks like this. So what is N and M? So with varying M and then holding N to be constant, we can see that as M increases, the steeper the softening arm is. So basically, it controls the slope of the softening arm. And then with varying N, holding M constant, as N decreases, the flatter the curve is at the yield point. So N here is 1, and then N here is 100. So to use the modified Ramberg-Osgood power law for this study, we devised two parameters, alpha and beta, in which we relate the normalized stress as measures to the experimental measures of stresses and strains as determined in experimental tests. So the MRO will need four parameters for the curve to be properly defined. We have M, N, alpha, and beta. And then the next problem is how we get this M, N, alpha, and beta. So we use the method of least squares to determine these parameters given a set of experimental strength results. So in a typical method of least squares, we minimize an objective function, which is the sum of the square of the difference between the observed stresses and the fitted stresses. So as you can see here, the fitted stresses will be solved by the modified Ramberg-Osgood power law. And then it is solved implicitly. So we solve it iteratively, typically by Newton's method. And then to determine the material parameter P, we use, and to implement the least squares method, we use the Levenberg-Marquardt algorithm, which equation is shown here. So it is widely used in solving nonlinear least squares problem. For our case, it is nonlinear. Okay, and then it is done iteratively. So the parameter matrix P will be solved iteratively. And for this case, for this problem, it is implemented in a code in C. Okay, so we run through different experimental data. So first we have experimental data from unconfined compression test of a dry clay sample as shown here. And then we fitted the MRO equation, and then we determine these parameters and then an R-squared value near unity. The same goes for a series of consolidated rain triaxial tests for silt samples. So for each curve, we fitted the MRO, and then we determined these parameters, and then the R-squared values are closer to unity. And then we also have this curve for CD triaxial test, wherein we have a residual softening arm here. Okay, so the R-squared value is a little less than 0.99 because of this curve. Okay, so the MRO curve typically just for one curvature only, concave downwards. And then we move to the plasticity model. For this study, we use the J2 failure criterion, or commonly known as the von Mises failure criterion, in which it defines yielding when a material second invariant of the deviatoric stress reaches a critical value. Mathematically, it looks like this. Geometrically, if a stress state is outside the cylinder, it means that the material has already yielded. And then we chose this failure criterion because of its extreme versatility, since it was used by many authors in developing more complex plasticity models. So we implement a stress integration algorithm in which we have this failure surface, and then we have an initial stress state. And then if we apply displacement, therefore there is a change in stress. Okay? And then if it is inside the yield surface, okay, it means that it's not does not yield yet. So therefore, this is the final stress state. However, if the elastic predictor gives us a yielding stress point, since the material is strain softening, the strength should deteriorate. Therefore, it will move back in, okay, a lower stress state, and then this will be the final yield surface. Okay, so these are the developed mathematical expressions for the J2 plasticity model for this study. Okay, as you can see, the MRO is already incorporated in the plasticity model, hence the J2 MRO naming. So, and then we also included the consistent tangent operator, so which are used to achieve asymptotically quadratic rate of convergence for Newton's method. So the closed form expression for the J2 MRO plasticity model was also computed and is shown here. Okay, so it is implemented easily using a computer program. So initially, we did an implementation of the model using one element 9-node quadrilateral in a C program. So we have two types of loadings, the stress loading and the strain loading. But for this presentation, we will only include the strain loading. So we imposed prescribed displacements in the boundaries of the quadrilateral, and then since it is strain loading, we can observe the post-peak response of the element. So hence we can see the strain softening, which we can't do in stress loading. So we did an axis symmetric compression using these parameters and then K to be a large value so that it is incompressible. So the result of the implementation agrees with the experimental data, the stress states, and then the vertical strain and the vertical stresses are computed as follows, and then it only needs 3 iterations per increment for it to converge. And then these are the stress values. So as you can see, it only in the y direction is the stress. So we also did that for plane strain compression instead of axisymmetric. So for this case, the stress results, the stress state results from the J2 MRO implementation also agrees with the experimental data. And then this is the load displacement curve. So the strain softening is also captured, and then the rate of convergence is also fast enough. It is quadratic rate of convergence, and it only needed 3 iterations for each increment of displacement. And then these are the stresses and strains experienced by the Gauss points. And then finally, we did that same thing for plane strain simple shear. Again, there's an agreement in the stress strains for the experimental and the J2 MRO. And then this is the shear stress and then the shear strain versus the shear strain curve. And then these are the stresses experienced by the element. So the shear stress for all the Gauss points are equal. And then these are residual values for the stresses. So after this, we are doing the geotechnical application. Okay, so we are looking at the deformation of soil under surface strip and circular footings. So strain loading for us to the expected output is a contour map of the stress distribution as we load the footing and then the plastic straining and then the deformations, of course. So initial conclusions, the use of the Leavenworth algorithm in determining the parameters of the MRO power law was proven adequate and repeatable. The developed J2 MRO plasticity model was able to satisfy consistency for both axisymmetric and plane strain conditions. And with the use of the consistent tangent operator, a quadratic rate of convergence was observed and the number of iterations to convergence was minimized. That's all. Thank you very much.
Thank you, Travis, for that presentation. And as we load the next one, I think Leia would like to acknowledge a few more of our participants.
Yes, Sir Reg. So we would like to acknowledge our participants from Mariano Marcos State University, Mindanao State University, National Taiwan University, National University, Nueva University of Science and Technology, Pamantasan ng Lungsod ng Valenzuela, Pangasinan State University, Partido State University, Philippine Central Islands College, Philippine Science High School, Pinma Cagayan de Oro College, Polytechnic University of the Philippines, Quezon City University, Romblon State University, St. Joseph Institute of Technology, St. Louis University, Sorsogon State College, Sorsogon State University, Technological Institute of the Philippines, Technological University of the Philippines, University of Science and Technology of Southern Philippines, University of the East Manila, Visayas State University, Western Mindanao State University, and Western Philippines University. So thank you very much again for attending our GRC.
Thank you, Leah. And again, welcome to everyone. We hope you'd be able to pick up some interest in the researches, as well as, of course, to some of you who are looking for topics, sana may inspiration na makuha kayo from the topics this afternoon. Our third presenter, allow me to share his presentation, is Amiel Mac Barros, who is presenting on sensor placement optimization in structural health monitoring. This is an application of offline selection to Bayesian sensor optimization. So these are case studies.
Good afternoon. So this is my presentation entitled Sensor Placement Optimization Structural Health Monitoring, and specifically on the application of offline selection to Bayesian sensor optimization. I'm presenting the theory as well as the case studies. To introduce you with the concept of structural health monitoring, it's a practice of diagnosing a structure to assess its safety and its useful life. And often it involves instrumenting a structure, and this needs very, very careful planning. In fact, the importance is highlighted by NSCP 2015 Appendix 1B. The locations of the instruments are selected to provide the maximum information of the building response from a major earthquake. This speaks of earthquake recording instrumentation, but this is also applicable to SHM, or structural health monitoring in general. So the question now is, how do you quantitatively maximize the obtained information? So this is the OSP problem. So there are 4 steps of optimizing the sensor configuration, as you can see here below. First is you need to identify the project parameters, determine the objective function, select an optimization algorithm for that objective function, and finally to implement this to an actual structure. Now, the problem is that in this framework, in the investigated literature, algorithm selection has been absent. So why is this important? Because one cannot readily assume that an optimization procedure will give the expected quality of results across the whole problem space. More often, engineers are not very familiar with the algorithm space. Therefore, a tool for choosing algorithms will be helpful. So the objectives of the study was to apply offline selection to a Bayesian optimal sensor placement framework. And we applied this to plate and a column and a benchmark SHM structure. So what we're going to see today are the results for the column and the SHM benchmark structure. Okay, hence the title, Application of Offline Selection to a Bayesian Sensor Placement Optimization. Starting with the OSP framework that you saw before, we now contextualize this to the OSP SHM problem. So what are the project parameters? So project parameters are theta, which is the feature of interest, for example, the model properties or the model properties. V is the sensor placement or configuration. Y is your structural response. So those are the project parameters. And from these, the objective function that we're going to use is a Bayesian-based objective function. So why are we using statistics? From the NSCP, again, we need to provide a certain configuration to maximize the information. And how do we quantify this? This is quantified through statistics. So what is the objective function that we're going to use? Without going too much into detail, this is the objective function. So maximizing this function here. So what does this say? So it basically says that we need a sensor location D star from this optimization problem that can maximize the probability of determining a certain feature theta, given a response data Y and a set of solutions D. So essentially, this says that the output of this maximization problem is the optimal D that will maximize the amount of information in a given response data and considering a certain feature theta. So that's the objective function. And now, how do you select the optimization algorithm? So the scope of the algorithms for this study was the covariance matrix adaptation evolution strategy. So all the selection algorithm, all the algorithms are CMAES. What is CMAES? It's a derivative-free randomized global optimization algorithm that relies on the continuous multivariate normal distribution. So it's useful for problems that have large population sizes and can be prone to local conversions, as in a case of optimal sensor placement. Okay, so apart from the continuous version of CMAES, we're also going to include in the algorithm space a discrete version of CMAES. And this is our formulation for CMAES using the multivariate binomial distribution. Okay, so essentially what we're doing is we're choosing between a discrete implementation of a continuous CMAES variant and the discrete reformulation of CMAES. Okay, so that's the selection that we're going to use. So in implementing this, first we implemented it in a steel column, 100 by 100 by 600, fixed supported on the base, and two cases. Case one, the existence of damage is unknown, and the damage, the structure is damaged, and the general location is known. So for this case, the general location is at E2. Okay, so implementing this framework, the project parameters are number one. We're going to use one sensor, and we're going to consider two cases. Objective function is the same as you saw earlier. And the selection algorithm, again, we're going to compare rank mu and discrete CMAES. How do we compare the two? We employ a parameter called the ERT. So this depends on the budget of your calculation and a certain hitting target. Okay, so applying that to this problem, so considering case one, assigning probability distribution of the elastic modulus for region 1 and for region 2, we identified that the optimal sensor placement is at the top of the steel column. Okay, so placing the sensor there, so the single sensor there, will grant you the maximum number of the maximum information. Okay, how about case 2? So case 2, we know that the general location is at E2, and hence E1 is undamaged. So we can already assume, we can already set that the elastic modulus at E1 is 200 GPa. So that's GPa, and at E2, since we don't know anything about E2, rather we know that it's damaged, but we don't know how much the damage is. We can assign a probability, a certain distribution at E2, and after running the algorithm, then we'll be able we determine that the OSP is at 500. Okay, so it shifted downwards to the location of the desired information. Comparing the performance of the two, so we start with rank CMAES after considering 100 different runs. So we were able to compute the DRT is 6. So the graph here shows a sample iteration of the objective functions. As you can see here, after it has plateaued at a certain iteration, then you consider the problem to be solved. Okay, so for the discrete CMAES, these are the plots. So as DRT is greater than the rank mu of CMAES, that means that the rank mu outperforms the discrete CMAES. Okay, so that means that rank mu is better in this problem. Now, how do you then implement it to an actual building? For an actual building, so we're considering the ASC SHM benchmark structure, which is a 2.5 by 2.5 by 3.6, 2 bay by 2 bay steel frame. And it has a published sensor placement. So what we're going to do, what we did was to compare the model properties that we obtained from this sensor positioning published in their paper with the actual OSP outputted by the algorithm. Okay, considering two cases, once again, undamaged and damaged. The damage is located at the first floor bracing. Okay, now using the same set of framework, project parameters are the same set of project parameters that we showed earlier, considering the two cases. The objective function is still the same objective function. And before I proceed to the implementation, we select which algorithm we're going to use. Okay, using ERT, so using the information from the case study before, we're able to determine that the rank mu CMAES outperforms the discrete CMAES 1.6 times. Okay, so we know that in implementing this framework, we're going to use rank mu CMAES. Okay, after running the algorithm, I'm showing you two sets of optimal sensor placement. So this OSP one, I'm just showing you in comparison to a result by Mr. Rahi and Kong. Okay, so as you can see, the red ones are our result, and the dashed lines are Mr. Rahi and Kong's result. And the sensors are located near the edges of the structure wherein the stiffeners are located. Stiffeners and columns are located. So this is another set of OSP. Okay. So in comparing the two, there's only a 0.53 difference in information. So you can use OSP1 or OSP2. Using OSP1 then to compare with the actual ASE sensor placement, what we're going to do is to compute for the modal properties using this sensor placement and using ASE sensor placement and compare the two. Okay, so these are the results of that comparison using a theoretical model, so finite element theoretical model. So these are the MAC values. So the higher the MAC values, the closer it is to 1, the closer the two vectors of model values are. So you can see they're all, so for mode 1 and mode 2, they're all close to 1. So what does this say? So for an undamaged structure, sensor placement that is well distributed according to the geometrical location of the columns and stiffeners gives the same quality of MAC values. So what about the damaged case? For the damaged case, when we run the algorithm, the sensors are located in the general region of the damage. Okay. Again, doing the same thing, we can see that there's a reduction of MAC for the ASE-SP. So using ASE-SP actually resulted to a deviation to the theoretical OMA. So that's in terms of the MAC. So for a damaged structure, the sensor placement should be near the location of the damage. So it's important that this should be identified in an SHM plan. To conclude, the OSP framework was improved by adding an offline algorithm selection methodology. For an undamaged structure, the OSP is a configuration wherein sensors are well distributed to the columns and the stiffeners. And for damaged structures, sensors should be placed near the region of the damage, and failure to do so compromises the quality of the OMA. So that's it. Thank you for listening.
Thank you, Amiel, for that presentation. And our next presentation is from Joshua Agar. Let me pull out this presentation file.
Good afternoon, I'm Joshua C. Agar, and I'm here to present my graduate research titled Site-Specific Evaluation of Hazard and Exposure of Typhoons in the Philippines using Tropical Cyclone Modeling and Large Eddy Simulation. This study focuses on typhoons, as the title suggests, which frequented upon the Philippines, that is situated along the typhoon belt, therefore being exposed to the hazards that typhoons bring, particularly severe winds, on which wind design provisions aim to address in the latest NSCP code. However, upon close review of the basic wind speed maps of the NSCP 2014 reveals inconsistencies between the extreme values and the contour maps. Comments also include failure to distinguish cyclonic from non-cyclonic winds. Pag-asa in its severe wind program aims to address the shortcomings presented earlier with its TCRM model, which generated and replicated tropical cyclone events to determine the cyclonic winds whilst retaining the GEV analysis for the non-cyclonic winds. The simulation of the typhoons included determining the main governing forces of the tropical cyclone, determining the storm's pressure profile, inclusion of the effects of the translation velocity, conversion of the regional winds to the surface winds using the exposure parameters such as gust factors and roughness lengths. However, these parameters for exposure were developed from the stationary and steady wind flow analysis. For complex terrains and urban settings, these parameters may no longer apply. A hybrid model was previously developed by Huang and Zhu in 2014, including now a CFD analysis to take into account the complex terrain effects, yielding closer results to the actual surface winds. What complicates every CFD analysis, however, is modeling turbulence. There are two turbulence models at hand. The Reynolds Average Navier-Stokes equation, or RANS, which treats the turbulent effects as additional average effects, and the large eddy simulation, which treats turbulent flow as the superimposition of eddies. The large eddy simulation originated from the energy cascade concept proposed by Richardson in 1922. Higher turbulent kinetic energy would mean wider range of eddies, which also mean higher peak gas. The previous hybrid model, since intended for aerodynamic purposes, runs in modeling turbulence, which would only account for the average effects, focusing more on the wind pressures. The study proposes to use large-scale dissimulation. The study aims to determine the site-specific parameters for wind hazard or the typhoon wind and exposure or the influence of the terrain. Wind hazard pertains to the magnitude of the typhoon sustained wind, while wind exposure pertains to gas factors, wind directionality factors, and wind profiles. The gas factors are the conversion factors used to determine the 3-second gas from the sustained wind given a degree of wind exposure. Wind directionality factor, in contrast to the NECP definitions, determines in which direction was the location most exposed to the severe winds. And the roughness length determines the horizontal mean profile near the ground. The methodology relies on the weather stations and the typhoon track to determine the pressure field of the typhoon. Using the pressure field, the typhoon wind field is then modeled, which is then used as an input to the CFD analysis involving a complex terrain. Once the simulated winds was validated with respect to the actual data, the site-specific parameters for exposure can now be post-processed. The study includes modeling of the pressure field from the weather stations, which observed the passage of the typhoon. The time history pressure data were then related to the proximity of the storm over time in order to determine the pressure versus distance graph. The pressure points were then fitted into a rectangular hyperbolic profile. However, the main difference is that the pressure isobars will be ellipses instead of circles. Thus, the radii of curvature will be determined also. Using the radii of curvature, the pressure gradient, the Coriolis force, and the centrifugal force, the typhoon wind field will be determined, which will be the input of the CFD analysis. For the CFD analysis as intended, LES will be used. The complex terrain is generated using the elevation data from OpenStreetMap. To reduce the computational load, the buildings are reduced to rectangular blocks but still carrying the key dimensions such as length, width, and height. Also, the computational model is scaled 1:10. As a result, the velocities are also scaled 1:10. Then the simulated winds will be compared to the recorded winds for the validation of the procedure. Post-processing includes fitting the boundary layer profile to determine the roughness length, the comparison of the friction-free surface wind to the local wind to determine the peak gas, evaluation of the directional deviations of the local winds, and the determination of the turbulence intensities. And the simulation study explored two scenarios, one in Typhoon Haiyan in Bantayan, Cebu at 8:30 a.m. and another one by Typhoon Nina or Nocten in Bicol in 2016, passing over Catanduanes. These are the comparisons of the recorded peak gas from the simulated peak gas. The winds simulated were originally instantaneous. Then getting the 2-second averages for Typhoon Haiyan's case yields a 2-second gas of 66.26 meters per second with a difference of 2.16 meters per second from the actual data. Being close enough, the other points of the computational domain were done post-process. Evaluating the roughness lengths, it reveals relationship with the building density. The higher the building density, the higher roughness lengths. The maximum gas factors are also related to the orientation of the alleyways. The more the alleyway is in the same direction as the general wind direction, the higher the peak gas. Plotting the directional deviation with respect to the gas factors reflected to the fact that as local winds became aligned to the direction of the general wind, the more it is more likely to build up momentum, resulting to higher wind speeds. In cases such as Osmeña Street, plotted here, so this one, where most of the mid-rise buildings are situated in Bantayan, Cebu, this caused the loss of the logarithmic profile, and it also caused downdrafts which damaged the already deteriorating Escario House at the end of Osmeña Street. For the case of Typhoon Nina in Verac, the wind flow across a kilometer-long domain was initialized after 25 seconds. With the flow imbalance resolved after the initialization, the flow began to exhibit its fluctuating characteristic. The simulated peak gas was determined to be 57.83 meters per second compared to the actual 54 meters per second. Some of the findings of the study include the increase of gasiness, showing a positive relationship with the change of elevation with respect to the general wind direction. Plotting the roughness length reveals how a roughness length changes over the change of terrain. From a more inlet terrain, the roughness length transition into a steadier value on which it was given a length to develop. Then, as it encountered a much more flatter runway, it transitions it to a new roughness length. Then, as the wind encountered the escarpment, shown here, a decrease in the roughness length is also observed from 0.18 meters to 0.06 meters. Also, the increase of gastiness shows a positive relationship with the increase of elevation with the general wind direction. The change of gas factors and roughness length are indicative of the flow separation, channeling, and reattachment, as illustrated here. So, this is the flow channeling where you observe increase in the gas factors but a decrease in the roughness length. We see what follows is the separation where we observe increase in roughness length but a decrease in gas factor. Then we have a reattachment where there's an increase in gas factor and a decrease in roughness length. The provisions and formulas for the turbulence intensity, on the other hand, only applies for the isolated conditions when comparing the prescribed turbulence intensity computed using this formula based on the code and the simulated turbulence intensity determined by the simulation. These are my references, and that will be all for my presentation. I hope there are many questions that will come underway. Thank you very much.
Thank you very much, Joshua, for that presentation. And before we proceed with the last two presentations this afternoon, I think Leia will be acknowledging some of our other participants.
We also have participants from public and private agencies. Welcome to Almec Corporation, AMH Philippines Incorporated, Capstone Engineering Services, DHI Water and Environment, DILG, DOLE, DPWH, JGC Philippines, Metro Stone Ridge Corporation, UPNCTS, PICE, Solar Philippines, C Squared Associates, and TOA Philippines Incorporated.
Thank you, Leia. And allow us to proceed with the presentations this afternoon. So the next presentation is from Ms. Nonalu Sherida Abaw. The presentation is on the determination of the commuting characteristics of school children in Valenzuela City and Zamboanga City.
Good afternoon, everyone. I'm Engineer Nonol Shurida Abaw, and I'm here to present this paper titled Determination of the Commuting Characteristics of School Children in Valenzuela City and Zamboanga City, Philippines. My co-author is Dr. Jose Regine Raydor. According to UNICEF and FIA Foundation, more than 500 children are killed on the road every day worldwide, and many of them die while they are on their journey to or from school. This is because children are still in the process of growth, making them more vulnerable to the impact of road injury. Their cognitive development is still in progress, and they have limited traffic experience. Moreover, roads were not designed with children in mind. So how do we create safe journeys for children between home and school? One helpful first step is by determining the commuting characteristics of school children to and from school. The results of the study can be a basis by policymakers in order to improve the safety of journeys made by students between home and school. The study is limited only to elementary and high school students in the Philippines. Also, as this research is part of an ongoing project on child road traffic Injury prevention of UNICEF Philippines, the areas that they have selected will also be the study areas of this research, which are Valenzuela City and Zamboanga City in the Philippines. As for related literatures and travel characteristics, the three literatures conducted surveys in urban areas, with samples consisting of elementary and high school students and their adult companions. Common mode of transportation is walking, and majority of students live within 5 kilometers from school. For literatures and safety vehicle devices, Nurbin et al. Said that for less risks of injury during vehicle crashes, it is best to implement both appropriate restraint use and rear row seating for children of all ages. Meanwhile, Bastos et al. Discovered in the study that there was a significant decrease in the non-use of motorcycle helmets due to higher penalties. Kemental said that patients who wore motorcycle helmets were less likely to have intracranial injuries and be admitted to the intensive care unit, and Foster et al. Suggested using bicycle helmets to protect the user from sustaining brain injuries and skull fractures. These are our study areas: Venezuela City, which is located in the National Capital Region, a highly urbanized city that has a land area of 44.59 square kilometers, and Zamboanga City, a highly urbanized city in Region 9 with a land area of 1,414.70 square kilometers but located in a more provincial setting. The dates of implementation of the pilot survey were from November 8 to 18, 2019 in Valenzuela City, while it was implemented from November 11, 2019 to January 7, 2020 in Zamboanga City. 25 schools participated in Valenzuela City, while only 24 in Zamboanga City. 30 students were randomly selected per school to answer the survey questionnaires. There were two sets of questionnaires, the to-school questionnaire and from-school questionnaire. Some students weren't able to return the from-school questionnaires. That is why there is an unequal number of to-school and from-school responses. For data collection mechanics, survey questionnaires were given to teachers of the schools and they randomly selected students from each grade level. These were given as an assignment to students to be submitted the next day. The following data were collected using the survey questionnaires. So for the survey results, in Valenzuela City and Zamboanga City, majority of the respondents are students and female. The usual ages who answered in Valenzuela City and Zamboanga City are 7 to 11 years old. Older respondents corresponded to children's parents or guardians. In Valenzuela City, students were enrolled in grades 1 to 6, while in Zamboanga City, students were from grades 1 to 12. One of the questions was, what was their main mode of transport to and from school? Main mode means mostly ridden mode of transport to and from school. So according to Valenzuela City students, their top three main modes of transport are walk, tricycle, and motorcycle to and from school. While in Zamboanga City, the top three main modes of transport are motorcycle, walk, and jeepney to and from school. Walking, which is the top main mode of transport in Valenzuela City, and riding the motorcycle, which is the top main mode of transport in Zamboanga City, is not surprising since most children reside near the schools. This information is supported by the estimated travel times between home and school. Majority of the respondents, 50% in Valenzuela City and 40% in Zamboanga City, said that students only take less than 10 minutes going to and coming from school. From the safety perspective, shorter travel time means lesser time to be exposed to traffic and other conditions that are related to road crash incidents. Longer trips in terms of travel time and distance generally means a higher likelihood for travelers, in this case school children, to be involved in crashes. In Valenzuela City, companions were present in all transport modes when going to school, while in Zamboanga City, majority of students who walk and ride the jeepney have no companions when going to school. Still in Valenzuela City, companions were present in all transport modes when coming from school, while in Zamboanga City, majority of students who walk, ride the school bus or van, and jeepney have no companions. Usual companions of students in Valenzuela City to and from school are their mothers. This may be due to the age of the participants, since those who answered in Valenzuela City are mostly up to grade 6 only, who are commonly 12 years old and below, while in Zamboanga City, the usual companions are their fathers. This may be related to the main mode of transport, which is the motorcycle. Fathers may be using their motorcycles to bring their children to school while on their way to work, but this still needs to be further investigated. In Valenzuela City and Zamboanga City, a large percentage do not wear helmets while riding the bicycles to and from school. Meanwhile, majority wears helmets in both cities when riding the motorcycles to and from school. In Valenzuela City, the common number of riders in a bicycle and motorcycle is 2 when going to and from school, which usually consists of the student and the companion. In Zamboanga City, the common number of riders in a bicycle is 2 when going to and from school. As for motorcycles, the common number of riders is 3 when going to school and 2 riders when coming from school. Although majority of motorcyclists use helmets, there's still a substantial number who do not. Reinforcing helmet use should be done since it was also found that the type of vehicle mostly used by children for their commutes is the motorcycle and that there are usually 2 or more riders on these vehicles. Majority of students from Valenzuela City who rode the car said that they did not sit in front of the car, while almost half of students sat in front of the car in Zamboanga City. Seat belts are still the widely used vehicle safety device in both cities. There were more respondents who used a child seat in Valenzuela City than in Zamboanga City. In the related literature mentioned earlier, it was recommended that to have the best safety benefits, children must sit at the back and use the appropriate restraint. For the 3% to 5% that have already encountered an accident in both cities, the usual location where the accidents happened occurred near school in Valenzuela City and near home in Zamboanga City while going to school. And accidents usually occurred near home in Valenzuela City and near school and near home in Zamboanga City while coming from school. Only about 12% of students in Valenzuela City have almost encountered an accident or have been involved in a near-miss incident compared to the 16% to 21% of students in Zamboanga City. The location where these near-miss incidents usually happen were at between home and school in both cities. The location where the accidents happened and almost happened needs to be visited to determine why accidents usually occur at the locations. Although with a limited sample, the survey results describe in detail the commuting characteristics of school children between home and school in Valenzuela City and Zamboanga City. Data can be a starting point in improving the physical environment to be able to provide evidence-based policies and measures to help keep children safe from road traffic injuries. Since walking is the most dominant mode of transport of school children in Valenzuela City, it is recommended to check on the walkability of the school surroundings. In Zamboanga City, the main mode of transport of school children is the motorcycle, so parents should strictly abide by the Republic Act number 10666. Also, a full-blown commuting characteristics survey is recommended to be done in Valenzuela City and Zamboanga City as a further study for a more detailed analysis of the travel characteristics of school children. So the authors would like to acknowledge UNICEF for supporting this research. Here are our references. Thank you for listening.
Thank you, Ms. Abao, for the presentation. And at this point, I'll ask Leah to share the last presentation. The last presentation is on numerical simulation of coastal sediment transport and morphology evolution along Ibahay Aklan coastline using Delft 3D. This is by Dominic Bautista.
Nick, and I'm here to present my research entitled Numerical Simulation of Coastal Sediment Transport and Morphology Evolution along Ibahay Aklan Coastline using Delft 3D. My advisor is Dr. Eric Cruz. So here's the outline of my presentation, and let me start by discussing coastal erosion in the Philippines. By definition, coastal erosion is the landward retreat of land, and in our country, more than 20 coastlines were identified as have been experiencing or had experienced coastal erosion due to the presence of various physical indicators such as the presence of scarps, changes in land, and the unrooting of trees in the coastal region. So in the Philippines, the assessment and monitoring of coastal erosion prone areas were headed mostly by the Marine Science Institute, and what they do in monitoring coastal erosion is they do collect photo or video documentation of the area after certain time periods. They conduct beach profiling and shoreline tracing. Now, these methodologies prove to be sufficient in providing possible causes, trends, and adaptation strategies to address coastal erosion. However, they lack relevant information on quantifying the different coastal processes that is essential when an engineering intervention is necessary to address the problem in the study area. So this is where my research will come in. So this study explores the advantages of using numerical modeling in assessing coastal erosion. So in general, numerical modeling can provide the following items which cannot be provided by the previous methodologies. So my study area is in the municipality of Ibahay, Aklan. So this is one of the areas tagged as experienced coastal erosion due to the presence of unrooted trees along the coastline and some scarps. So it is a third-class municipality with fishing as a primary source of livelihood. There are boats parked along the coast and households present around 10 meters away from the coastline. So there's also a mangrove eco park and a small stream that discharges into Sibuyan Sea. So the main objective of this research is to create, simulate, and analyze the hydrodynamics, wave, sediment transport, and morphology evolution of the study area using a calibrated three-dimensional Delft 3D model. So along these main objectives are the following specific objectives. So the scope and limitations of this study are the following. First, the modeling platform that I will use is Delft 3D. So the analysis or the governing equations will be limited by the mathematical models and numerical solution of the platform. Also, the modeled scenarios will be two. The first one is a long-term simulation under prevailing wind and wave conditions, and the other is a short-term under extreme conditions. Specifically, this is Typhoon Frank, which devastated the area last June 2008. Now, there is a limitation in available data. So the sediment transport was not calibrated, as well as the data during the typhoon event. So this limitation accounted by ensuring that the main driving forces from hydrodynamics and waves are calibrated. So from this, the sediment transport can be assumed as okay or reliable in terms of the simulation results. And the parameters that was used in calibration for the hydrodynamic and wave models were used during the typhoon event. So in addition, the typhoon parameterization was calibrated as well. So to account for the lack of data during the typhoon event. So here's the research methodology. So there are a lot of data gathered in this research. So we gathered meteorological data by installing a portable weather station. We conducted a bathymetric survey using single beam echo sounder. We also gathered primary data that was used for calibration using a set of sensors deployed at this point in the study area. We also collected a sand sample and underwent sieve analysis and obtained a mean diameter or median diameter of this value. There are also a lot of secondary data gathered from GEPCO and NAMRIA for bathymetry, from DOST ASTI and the Global Forecast System for prevailing wind data. Wind data during Typhoon Frank was obtained from Pag-asa meteorological stations in San Jose Station and Roa City. The typhoon track data of Typhoon Frank was obtained from JMA, and wave boundary data from WaveWatch 3 hindcast results on Sibuyan Sea, tide boundary data from the Global Ocean Tide Inversion Model TPXO 8.0, and the water level forecast from IHO on selected tide stations were used for validation of the simulated water level data in the numerical models. So there's also a secondary data for the stream discharge, which came from an unpublished SWOT simulation of the stream watershed. So in this research, 3 computational domains of varying extent and resolution were created. The largest is called the regional model. This one is the local model covering the northern coast of Panay, and the nearshore model, which is exactly on the study area, which covers the study area. So the next few slides are the properties of the different computational domains. So this is for the regional model, this is for the local model, and this is for the nearshore model. So here's a flowchart of the model calibration conducted in this research. In the absence of the data for calibration of the sediment transport model, they are not conducted here and stopped at the wave and hydrodynamic model only. So only the default values for the sediment transport model were used in this study. So in assessing the response or the simulation results, use this literature from Williams and Esteves, which provides some guidelines on assessment of calibrating and validating hydrodynamic wave and sediment models. So they provide guidelines to assess whether your model is good enough to simulate the actual conditions in the study area. So the next few slides shows the result of the calibration of the 3 computational domains. So this one is for the regional model calibrated with respect to the water level values. The Typhoon Frank parametrization is an important parameter. When you have a typhoon and you want to include the effects of that typhoon in a numerical model, in Delft 3D it was included as a spider web, which provides the spatial and temporal variation of the wind profile. So this parametrization is done in Delft dashboard, and to assess whether this spider web actually captures the variation of wind and pressure in the model, it was compared with the measured wind speed and direction in the 2 Pag-asa meteorological stations. So, and another validation during Typhoon Frank is the response of the water level at Katiklan Station. So, as you can see, the simulated water level during the peak of Typhoon Frank was captured using the calibrated parameters of the regional model. So, and then this is for the local model. So, and the next is for the nearshore model, which is the most important one. So, these are the results of the calibration of the hydrodynamics, and this is for the waves. So for the results, the hydrodynamics in the nearshore model under prevailing conditions has 2 patterns. During ebb tide, the water moves from the lateral boundary at high speeds. From the lateral boundary, it moves towards the center at a speed of 0.5 to 1 meter per second. During flood tide, the flow reverses, but it is at lower speeds. So this will have a significant effect in the transport of sediments, which will be discussed in the succeeding slides. The comparison of bottom velocity and surface velocity can be shown or can be seen in this slide. So the bottom velocity under prevailing conditions follows the direction of the surface velocities, but it has lower speeds. For the waves, since the study area is facing the Sibuyan Sea at the north, southwest monsoon winds do not affect the growth of the waves. In fact, the waves during this season only reach up to 0.1 meter. On the other hand, during northeast monsoon season, the winds intensifies the approaching waves to the coast, reaching up to 1 meter height of waves. So in terms of sediment transport, this plot shows the bed shear, bottom shear stress, which causes the movement of sediments in the bed layer. So there are 2 areas of active sediment transport patterns observed based on model simulations. The first area is near the lateral boundaries caused by high-speed currents, and the second area is near shore where waves break, creating turbulence. So these 2 areas were identified as the areas where morphology changes are expected. So here there are 2 areas near the lateral boundary caused by tidal asymmetry. As mentioned earlier, during ebb tide, the currents are strong enough to move the sediments towards the center of the domain. And then during flood tide, the flow reverses. However, not as strong as the ebb tide, which means that not all the moved sediments will be transported back to its original position. In effect, the sediments are deposited somewhere in the center, okay, and the area near the lateral boundaries were eroded. For the nearshore area where wave breaking occurs, because of wave breaking, the turbulence creates an uplift force causing the sediments to be lifted. Now, if the period of the waves is short enough such that once the sediments were uplifted, the incoming waves will push those uplifted sediments onshore, causing them to deposit forward the coast, as what can we see in this simulation result. Now, I also tried simulating the morphology change after the northeast monsoon season only. So in this slide, it shows that the effect of the northeast monsoon season is higher as compared to the entire one whole year simulation. So this indicates that because of the more active wave processes and hydrodynamic processes, the sediment transport is more active as well, causing deeper erosion and deposition in the study area. Now, during southwest monsoon season, where the processes are calmer, it promotes recovery of the moved or the transported sediments and comes back to its original position. Okay. So yeah, beach profiles can also be plotted in the numerical model, as you can see here. So the beach profiles reflects the changes in morphology due to wave action near shore and due to tidal asymmetry somewhere offshore. Okay, and recovery during wet season can also be observed in the beach profile if you compare the after dry season and 1 year simulation. So we can also plot the change in the shoreline position, as can be seen here. And based on this shoreline tracing or the traced shoreline, we can see that the coastline moved seaward, indicating that the coastline is accreting. So since it is accreting and not eroding, any engineering intervention is not necessary anymore. Now, in terms of the typhoon conditions, the selected Typhoon Frank, was done, the selection of Typhoon Frank was done based on the historical shot of this study area. So this study area, or this shot in the study area, showed significant erosion. Was taken August 2008, and investigating the tracks of the typhoons passing through the study area. On this time, only Typhoon Fengshen has the most significant relative sa study area. So the hydrodynamics during Typhoon Frank. So this plot shows the surge based on the simulation results. Okay, so the maximum surge height is 0.8 meters. And this plot shows the snapshots of the velocity during Typhoon Frank. And you can see that there's a longshore current, which is significant in the movement of the sediments. So in terms of comparison between the bottom and surface velocity, we can see that the bottom velocity does not follow the direction of the surface, because the surface velocity is greatly affected by the surface winds caused by the typhoon. So, and this one shows the wave climate or the snapshots of the wave conditions during Typhoon Frank. So as you can see, wave heights reach up to 2.5 to 3 meters during its peak, and it follows the direction, or it's greatly affected by the direction of the surface winds. So in terms of the morphology, the effect of Typhoon Frank caused a change in elevation of at most 1 meter. And the effect of the tidal asymmetry still caused some erosion and deposition near the lateral boundaries. There's also the presence of the west-east longshore current eroded the center portion of the near shore, as you can see here. And the onshore transport due to wave action is still present. Okay, so the eroded sediments in this area were transported onshore because of the breaking of waves. So looking closer at the stream map, we can see that there is no significant erosion simulated. This indicates that the erosion in the previous picture in the Google Earth shot last August 2008 was caused by the heavy discharge from the stream during the typhoon, which was not accounted in the simulation. So the tracing of the shoreline indicates that the coastline was slightly eroded, only slight, and it was recovered immediately after one season of northeast monsoon. So in summary, in conclusion, a calibrated hydrodynamic model with sediment transport was successfully created that can predict the hydrodynamic and wave conditions in the study area. So under prevailing conditions, the sediment transport patterns were observed caused by tidal asymmetry and wave breaking, and areas of erosion and deposition were identified based on simulation results. And finally, analysis of the traced shoreline indicate that the coast is accreting under prevailing conditions and slightly eroded after Typhoon Frank. And finally, we can say that numerical simulation provides a more holistic approach in assessment of coastal erosion as indicated in results of this research. For future improvement of this work, calibration of the sediment transport model will improve the accuracy of the simulation results. We can use the following data if available, and more accurate hydrologic modeling of the stream will complete the features of the study cost. So that's it, and thank you very much for your attention.
Thank you, Mr. Bautista, for that presentation. Allow me just to share my screen. Hindi ko nagagawing slideshow mode ito, no? But just for us to have a background, as we open the floor for the open forum. To those of you who want to still type in their questions dun sa Q&A, we'll be very happy to read those, no, just in case ayaw nyo magsalita. But in case you want to ask questions live, just please raise your hand, no, and then maybe identify yourself, your affiliation, no. But before we open the floor, no, for the questions, no, from the attendees this afternoon, allow me to first acknowledge, no, our faculty members who are attending this graduate research colloquium. Of course, we'd like to mention academician Dr. Benny Pacheco. Thank you for attending this afternoon. Dr. Tanchuling, thank you at nakahabol doon sa ating GRC. Dr. Palmiano, who heads our transport engineering group. Dr. Verhel is also here, Carl Verhel. Dr. Aquino, who is our deputy director. And also Dr. Cruz, no, is also here. He's the advisor of Mr. Bautista, who presented earlier, Dr. Ambrosio. And hindi ko nahabaan siguro, no, pasensya na doon sa mga hindi ko binanggit in the acknowledgements. So at this point, maybe we can open the floor to questions. We have one raised hand from Mr. Will Ross. Yes, I think you may unmute yourself and ask the question. Yeah, Mr. Will Ross, your hand is raised.
Sorry. I just click it, sorry.
Okay. Thank you. Anyone who have questions for our presentations? We had 6 speakers. Mr. Rochi Amulato, Mr. Matthew Travis Alcantara, Mr. Amiel Barros, Mr. Joshua Agar, Ms. Nonalu Sherida Abaw, and Mr. Dominic Bautista. We have a good mix actually of presentations this afternoon, no? And I think baka dinadigest pa ng ating mga attendees, ng ating mga participants yung presentation. So maybe a very general question, no? Just to start the ball rolling. General question siguro. Regarding the replication of those researches, kasi we understand, of course, may mga study areas, no, na binanggit dito. Maybe we can ask any of the speakers, how is the replicability of your researches in other areas? Kaya bang gaano ba kadali, gaano ba kahirap gumawa ng model, for example, no? In other areas, no? Para ma-apply itong mga researches na ito. Maybe we can ask our speakers if you can turn on your videos para makita natin yung mga speakers natin. Yeah, Joshua? Unmute
Yes
yourself.
po.
Yeah.
Yes po. Start to start the answering the question po. Replicability, yes, kaya, pero yung computational demand po medyo mataas sa part ko.
So in your case, kasi we understand that you have several study areas, no? So those were several islands na nagkaroon ng simulation. When you say computational requirements, no? What do you really mean about computational requirements? May mga ano ba to? May mga limitations ba, constraints regarding yung computer na kailangan mong gamitin, computing power?
Yes.
Gaano ba kalaki yung mga files na na-generate nitong mga simulation na to?
Yes po. In terms of computational demand po, bukod sa mataas yung requirements niya for the processing capacity, matagal din po actually yung simulation time. Even running on an HPC po, tumagal ng 2 months po yung simulation, especially for the Virac case.
Thank you, Joshua. Allow me to read some questions, no, coming from the Q&A box. This comes from John Philip Lapides to Dominic Bautista. What are the averaging periods of the wave boundary applied and the wind forcing used? And what is the model time step? Thank you.
Yes, sir. Thank you po. Thank you for the question. Averaging periods of the wave boundary, are we talking on the time step of the time step nung input or yung period ng mga waves na nandun sa boundary? In terms of kung yung time step, no, that is yung ginamit is 3 hours since yun yung available na data dun sa WaveWatch 3. In terms of the period, since it's composed of the both swell and wind waves, based on the simulation, it ranges from 2 to 4 seconds. So yun yung average periods. Now for the wind forcing used, yung sa global forecast system also ay 3 hours yung time step, pero yung doon sa DOST ASTI na wind data is 15 minutes. So what I did, kasi if you compare the measurements nung dalawa, yung sa GFS overestimates the wind growth nung waves kasi nasa gitna siya ng Sibuyan Sea. Pero yung sa DOST ASTI na wind station, underestimates naman kasi nasa inland siya. That's why I averaged yung dalawang wind data and arrived at doon sa more or less okay na values. So what I did is I averaged yung 3-hour na wind data sa Kalibo and then tsaka ko kinumpare with the GFS. And for the model time step, it depends kung anong model, no, sa regional and local and nearshore magkakaiba yung model time step, depende dun sa numerical na requirement. So kasi kapag masyado mataas yung time step, it's possible na hindi siya mag-converge and mag-error. But if you're asking for the actual, I believe yung sa nearshore model, it's 0.25 minutes. 0.25 minute. So that is 15 seconds na time step. So yeah.
Thank you, Mr. Bautista, for that answer to the question. There's another question here, this time for Ms. Abaw. Why did you choose the two cities, Valenzuela City and Zamboanga City, for your research instead of other places?
Well, I mentioned in the presentation earlier that since this research is part of an ongoing project of UNICEF, the areas that they have initially selected will also be the areas of this research. So it was UNICEF who chose the areas. Also, for the replicability of the research, I believe it is easy to replicate because you just uh, do survey questionnaires. That's all.
Thank you. Thank you for that answer. We'd like to invite more questions for our speakers this afternoon. You may type your questions or you may... Ay, ito, nasa chat, sorry. Hindi ko nakita kagad. Okay, so there's a question here. This comes from Miss Erica Gomez. And this is a question for Mr. Bautista. I have a question. Are the methods for erosion, accretion, tracking reliable for the Pacific Coast areas like in Eastern Samar and Region 5? And then follow-up question, does the Aklan Coast being surrounded by islands matter? So yun yung questions.
Yes, thank you for the question. No? So, let me answer first yung una. Are the methods for erosion accretion tracking reliable sa ibang areas? Yes, the general methodology conducted in my research can be used to other areas of concern, but please make sure that yung parameters na ipapasok dun sa model are heavily site specific kasi. So doon sa site ko which is in Ibahay, Aklan, the composition of the sand is almost uniform. So that's why I use the simplest sediment group which is non-cohesive na sand, no? For other areas, it's possible na yung sediment composition is different. Like for example, if there are corals, no, then that's a different story. And kapag meron pang river na nagde-discharge ng malaking river na significantly nagde-discharge ng cohesive sediments, then that's a different approach na dun sa input parameters dun sa model. But the general approach, the data that should be gathered, the way of to analyze can be applied or transferred dun sa other sites in the Philippines. And for your second question, does the Aklan Coast po being surrounded by islands matter? Yes, definitely kasi the surrounding area, well, if you've checked yung sa research ko, I used three computational domains nested with each other. The reason kasi is yung site is in an internal sea, no, and the boundary conditions must be dun sa mga deeper portions. Yung mga global data sets are more accurate dun sa deeper portions ng ocean kasi global ocean models yan eh. So since nasa loob ng internal sea yung site ko, I have to use a large domain tapos papasok dun sa study area. So definitely the areas or the geography of the surrounding area is greatly affects yung hydrodynamics and the wave conditions dun sa study area. Thank you.
Thank you, Mr. Bautista, for the reply to those questions. Can we invite more questions coming from our attendees? Maybe some of our faculty members also would like to ask some questions regarding the research topics that were presented this afternoon. Ito, may question. For Mr. Alcantara, where is the J2 MRO plasticity model applicable? Can this be used to any type of soil or any type of condition? So, yun yung questions.
All right. Thank you po for the question. So the current formulation of the J2 MRO plasticity model is for strain softening soils, but it is also limited to soils that is in drained or dry condition. So the pore water interaction is not considered in the current formulation. Also, it is only applicable to monotonic loading. So yung cyclic loading and then yung dilation factor ng soils, hindi siya considered. Tapos sir, isagutin ko na rin sir yung in terms of replicability ng study. So yung dina-develop na plasticity model, basically kapag natapos siya tapos we found that it is stable when applied to a larger geotechnical engineering problem, it can be used to analyze progressive failures in kahit different situation basta geotechnical. Ganun yung assumptions ng problems. Ayun po.
Thank you, Mr. Alcantara, for answering that question. We have 3 more questions here. I think we can accommodate them before we conclude the GRC this afternoon. For Ms. Abaw, there's another question here. Can we apply the same study concept in different locations during this time of the pandemic? No? So will it still have the same impact on transportation planning in the area? So I think this is related to the pandemic. Kailan ba ginawa yung study? Was it pre-pandemic or during the pandemic?
Well, we did the study pre-pandemic, and we asked the students what were their commuting characteristics pre-pandemic. So during this time of pandemic, I think it will be challenging because one of the question there is what is their main mode of transport to school and from school. So what will they answer? Right now we're having, or we do not have face-to-face classes. So students are just at home. So I think it will be challenging to do this research during this time of pandemic.
Okay, thank
That's
you
all.
thank you for that reply. So I understand it's a recall survey. I'm the co-author of the paper, kaya it's a recall survey, no, pre-pandemic conditions. Another question again to Sir Dominic. What is the difficulty in replicating your study? What would be the recommendation? Should an undergraduate student be doing research along the lines of your study?
Okay. In terms of difficulty, I would say it's
Kaya ba ng undergrad yan?
well, hindi po siya advisable na individual tapos undergrad, no. But yeah, in terms of difficulty, it's really difficult. As you can see, we have a lot of data gathered primarily from the field surveys. So the most crucial information or the data we gather there is the data we used for calibration. Because the calibration process of any numerical modeling is necessary such that your model sufficiently captures the processes in the study area. So kung wala yung calibration na parameter or na calibration na data, so it might be questionable kung accurate ba yung nilalabas ni model mo with regards dun sa gusto mong alamin. So, yun siguro yung pinakamahirap na part, yung pag-acquire ng calibration data. Kasi sa Philippines, mahirap talaga. Wala tayo, very limited yung data natin sa Philippines. And I was lucky enough to be part of a project that did a field survey na merong data. But in terms of, yeah, yun yung pinaka-crucial. But the rest of the data sets, you can get from global data sets na ginamit ko. You can also use that for the general na parameters na ipapasok mo dun sa model. So, yeah, so for general purposes, you can replicate it, no, but the question is yung accuracy. Tama ba yung nilalabas ni model mo? And the answer to that will come from yung calibration, yung i-compare ng yung pag-compare ng model results with the observed values. So yun yung magsasabi kung tama ba siya. So for undergrads, medyo mahirap siya kasi nga mahirap makahanap ng calibration data.
Thank you, Mr. Bautista. Last 2 questions. For Mr. Barros, question, are there guidelines or recommended number of sensors for SHM?
So actually, if you check yung Appendix 1B po ng NSCP, we have certain guidelines there. Pero yun po is specifically for earthquake recording instrumentation. For SHM in general, so there are two types of operational modal analysis testing. First is yung preliminary called the modal test. So during modal test, you need to place as many as sensors as you can. So just this is to increase yung tinatawag po na spatial detail nung maglalabas na moche. Afterwards, for a more permanent sensor positioning, one or two would suffice. So one or two triaxial sensors would suffice.
Thank you for that reply. Maybe the last question, I'll just read it out. Again from Mr. Philip Lapides. Mr. Bautista again. Maybe you can consider checking the averaging period used, especially when you combine 15-minute winds with 3-hour winds. It was mentioned that the wave height boundary condition applied corresponds to 3-hour sea states. Is 3 hours fine enough to resolve erosion events during typhoons?
Yes, thank you. Thank you po for the question, no? So, and for the comment regarding dun sa pag-combine. Actually, it's just a simple solution. Well, I'm not sure kung valid ba talaga yung pag-combine, but I was just playing around with the available data at hand when I arrived at that good enough solution dun sa comparison ng wave heights. Kaya yun yung ginamit ko. But to answer your question, is 3 hours fine enough to resolve erosion events during typhoons? For the long-term simulation, I think 3 hours is good enough for the 1-year simulation. But during typhoon events, unfortunately, it's not a matter of if it's fine enough or not. It's a matter of kung ano yung meron. So it's the only available data I have with regards to wave boundary conditions. So it's the one I used because it's the only available data. Other global data sets for waves also has a 3-hour resolution for the wave boundary, which is why yun pa rin yung ginamit ko. But thank you for the comment and thank you for the comment.
Thank you, Mr. Bautista. May pahabol dito siguro, so we'll just accommodate this last question. Mr. Alcantara, it seems that it is presumed that we have lab data so that we can use LM for fitting, but to be able to be useful in practice in the absence of lab curves, then we either, number one, generate parametric experimental curves, or two, make the MRO parametric that will depend on strength, elasticity, and dilatancy parameters. Are there future plans for this?
All right. So, yung sa first question, yes, we can generate parametric experimental curves. Actually, that was the first part of this study. So, but we only did the parametric analysis for the current parameters. And then for the second one, in terms of strength, elasticity, and dilatancy, we are actually starting to extend the MRO power law by adding parameters that as of the moment, there is one undergraduate research that will take care of the residual asymptotic softening arm. So, as of the moment, yun pa lang yung tinitingnan. But yes, we can explore on how to adjust or add to the current equation to see how it will go with the strength, elasticity, and other parameters. Thank you, sir.
Thank you, Travis, for the reply. At this point, we'd like to wrap up our GRC this afternoon. Allow me to just conclude our second GRC. So we thank everyone on behalf of the Institute and our Institute Director. We would like to thank everyone for participating this afternoon. We'd like to thank our speakers, Mr. Amolato, Mr. Alcantara, Mr. Barros, Mr. Agar, Ms. Abaw, and Mr. Bautista for their presentations. And for the participants, our attendees, thank you for your questions, your comments this afternoon. To our faculty, thank you very much also for attending our GRC. And we hope to see you again in future GRCs. Definitely, we'll be following this up with another GRC, perhaps towards the end of this year or early next year in 2022. There are certainly a lot of material that can be shared, that can be disseminated in as far as the researches are concerned. And allow me to plug. We will be having a professorial chair colloquium towards the end of this month. That will be on October 20 to 29. So abangan nyo na lang po yung announcement through the usual channels, including our Facebook page sa Institute of Civil Engineering. We will be posting about that professorial chair colloquium, which will be spread into 2 days. Our professorial chair holders will be giving lectures, presentations on their topics. And yeah, abangan na lang natin yung announcement ng ICE regarding that. Allow me to reiterate rin yung if ever you're interested to connect with us regarding itong mga research topics na na-present today as well as yung mga nabanggit natin kanina, you're very welcome. Research is always a collaborative effort. Hindi lang sa UP, hindi lang sa Diliman. Of course, we welcome collaborations with other universities as well. Kita naman natin yung mga locations ng mga researches, iba-iba. So, mula Luzon hanggang Mindanao, di ba? So, yung coverage natin. So, I'm sure that these collaborations are very welcome. Okay, so, Lea, sino bang kukuha na? Paano bang
Travis
mangyayari?
will take screenshots.
Okay.
Ilang page
Alright.
Ating official photographer. Okay, so
2 pages tayo,
Okay.
everyone. Sige, page 1 na po muna. Well, smile na lang po tayo consistently. Alright, 1, 2, 3, smile. Isa pa po for page 1 for redundancy. 1, 2, 3, smile. Alright, page 2. Pero smile pa rin tayong lahat. Okay. 1, 2, 3, smile. Isa pa po. 1, 2, 3, smile. Alright, okay na Sir Reg.
thank you everyone, and we wish you a nice and safe weekend. Salamat sa pagdalo dito, pag-attend dito sa ating second graduate research colloquium. So enjoy the evening. Thank you and good evening everyone.